Good evening, my YouTube viewers. Crystal here. I wanted to make another video for you. This video is on the Kaggle competition question, house prices, advanced regression techniques, and it's based on the Ames House Prices datasets. I wanted to show this to you because just today, just 3 hours ago, I did some work and I got my score to 0.13404. I know that's not the best scores. The best score is 0.00044, but it's a pretty good score for me. I've not been able to get it any lower than that, other than one time when I was using an N symbol. I got it down to 12. Now, what I wanted to show you was, in order for me to get this down to 13404, I was using the sklearn's ColumnTransformer, and so I was using gradient boosting regressor, and the only difference between the gradient boosting regressor and the ColumnTransformer was that I was using ColumnTransformer, but other than that, I used exactly the same data, exactly the same model. So what I wanted to do is I wanted to go over this program with you using ColumnTransformer. So we've come up onto the Ames House Prices, and you can see I'm sharing this program. But what I will do is I will leave a link to the program in the description box down below if you want to click onto that and share and go over it with me. So the first thing we'll do for this Ames House Prices is we'll go over the problem statement. So your problem statement is, ask a home buyer to describe their dream house, and they probably won't begin with the height of the basement ceiling or the proximity to an east-west railroad. But this playground competition's data set proves that much more influences price negotiations than the number of bedrooms or a white picket fence. With 79 explanatory variables describing almost every aspect of residential homes in Ames, Iowa, this competition challenges you to predict the final price of each home. The Ames housing dataset was compiled by Dean DeCock for use in data science education. It's an incredible alternative for data scientists looking for a modernized and expanded version of the often cited Boston housing dataset. So the first thing we would do is, first thing I'll say is I'm in the Kaggle Jupyter notebooks. Now, I wrote the program in Google, but you have to transfer it over to Kaggle Jupyter notebooks, which is what I did. So the first thing we did was we import our standard libraries. So these are all the standard libraries that we would need, and you can see what their versions are. And so you'll see we use sklearn a lot, and sklearn we're going to be in version 0.23.1 because that's what I spend a lot of time in. I spend a lot of time in sklearn. And then we're going to import OS, which is the operating system. And when we import OS, we're going to call up the actual files that are in the directory that you can use, well, that you'll need to use to answer this competition question. Specifically, you're going to need the train file and the test file, and you will also need the sample submission because you need to find out what Kaggle wants to see when you're submitting your predictions. Then what we do is we load our data sets. So we load our train file and our test file. We read our train file, and you can see it's about 80 columns of data, 81 columns to be precise. And then we read our test data set, and that's 80 columns of data. So, and our test file is 1,460 rows, and on our train file is 1,459 rows. And so now what we do is we describe our target variable. So we've got our sale price, so you can see what the sale price is in comparison to the other prices, and it tells you what they are. And then here's a graphical representation of the sales price and how it relates to the overall quality. So now what we're going to do is we're going to check for null values. But since there's so many columns and there's so many null values, I had to use special coding to actually check for the null values. And we check for null values in the train file and the test file. So you can see all of the columns that have null values. Some of these columns are going to be numeric and some of them are going to be categorical. Now what we're going to do is we're going to describe our x, y, and x test variables. So y equals train.sellprice.values. X equals train drop sell price drop ID axis equals 1. X test equals test drop ID axis equals 1. And now what we're doing is we're setting up identify numerical and categorical features and preprocessed data. So this is where we get into the actual ColumnTransformer bit. So whenever you're doing this ColumnTransformer, you can either type in your numeric features. You can type in your numeric features using the actual name of the column, or you can type in the numeric features using the number of the column. And I decided that since there are so many columns that I was going to type in the number of the column, but you're not typing in the number of the column of the train data set. You're typing in the number of the column of the X data set, and the X test data set should be the same format as the X data set. So you have to make sure that you don't put the number of the train data set columns. You have to put the number of the X data set columns. And then when you put the number of the X data set columns, then you're going to put it through a numeric transformer equals pipeline steps imputer. And because it's numeric, I decided to put it into an iterative imputer, random state 1, and scalar, standard scalar. And then we do the same thing with the categorical features. You use the column numbers of X. And then we categorical transformer equals pipeline, steps equals imputer. You have to use simple imputer because iterative imputer won't work on a categorical data, or I haven't found it to work anyway. And then so strategy equals constant and fill value equals missing. So, and then you do one hot encoder. So what we're going to do is we're going to one hot encode all of our categorical data. And then we define our preprocessor equals ColumnTransformer. Transformers equals num, numeric transformer, numeric features, and cat, categorical transformer, categorical features. So as you can see, we've defined our numeric features, our numeric transformer, our categorical features, our categorical transformer, and our preprocessor. Now what we're going to do is we're going to split our train data set up for training and testing. But it's not really the train data set that we're splitting. It's really the X data set that we're splitting. So X train, X val, Y train, Y val equals train test split. X, Y, test size equals 0.1. Random state equals 1. And then I put shuffle equals true, but it doesn't make any difference. If you don't have shuffle equals true, it makes no difference. And then we want to check the columns. We want to check the shape of each column we're going to be using. So we're checking the shape of X train, X val, Y train, Y val, and X test. And now what we do is we're going to make another pipeline. And this pipeline is going to define our model. So model equals pipeline Steps equals preprocessor, regressor, gradient boosting regressor, random state equals 0, n estimators equals 400, max depth equals 5, min sample split equals 2, learning rate equals 1, loss equals LS. Model fit, X train, Y train. You print it, and then our accuracy is 999,547,1055,3629. So we check our sklearn metrics. So what we're doing now is we're predicting on X val, and so we import our sklearn metrics, import R2 score. So ypred equals model.predict xval, ypred equals ypred as type int, print model.score xval yval, print R2 ypred model predict xval yval. So you've got an accuracy of 0.95, 18336226045,191, and then on your R2 score you've got 99. So that's pretty good. Now we make a data frame where you can compare the actual values against the predicted values. And now what we're going to do is we're going to predict on X test, and we're going to call that final labels. And we predict on that, and you get final labels is an array. So we're going to create a data frame equals final result equals PD data frame. ID is test ID. Sell price is final labels. Then we're going to submit our predictions. So final result to CSV is submission. CSV index equals false. And then you get a little notice saying that your submission was successfully saved. And now we're going to upload the submission. Submission equals PD read CSV, submission CSV, and submission, so you can read what you've done. So we come down here, and we've got our submission. And if we wanted to submit it, which I'm not going to submit it because we've already submitted it in the past, then we got a score of 0.13404, which isn't too bad. It's not the best score, but it's respectable, and it's better. It's better than the previous submission that I made, and the only thing that I did was I used ColumnTransformer. So the previous submission that I made was 0.15314, and this new position is 0.13404, so that's like 2 points improvement using ColumnTransformer. So I just wanted to show that to you, and